So good morning to all of you. Now I'm going to take up mathematical modeling, and let us start with the definition of mathematical modeling. Mathematical modeling is an attempt to study some part or form of the real life problems in mathematical terms. Okay, and a mathematical model, when we are talking about mathematical modeling, we use the word mathematical model. Mathematical model is a mathematical relation that describes some real life situation. For example, you have solved problems in simple interest using the formula for finding it. The formula or equation is a relation between the interest and other quantities that are related to it, that is the principal, rate of interest, and the time period. That formula is an example of mathematical model. So mathematical model is a mathematical relation that describes some real life situation. Okay, and the process of translation of real life problems into mathematical form can give a better representation and solution of certain problems. The process of translation is called mathematical modeling. So we are using mathematical model in our process, that is process of translation, that is called mathematical modeling. In mathematical modeling, we take a real world problem and write it an equivalent mathematical problem. We then solve the mathematical problem and interpret its solution in terms of the real world problem. After this, we see to what extent the solution is valid in the context of the real world problem. Okay, so now let us move towards some examples where mathematical modeling is of great importance. Are a few examples I have taken. First one is finding the width and depth of a river. Second one, estimating the mass of the Earth and other planets, estimating the distance between Earth and any other planets, predicting the population of a city after 10 years, and estimating the number of leaves in a tree, and estimating the number of fishes in a pond, and estimating the temperature on the sun's surface. So these are some a few examples where mathematical modeling is of great importance. And now let us go through the advantages of mathematical modeling. Models exactly represent the real problem situations. This is the first advantage. And the second advantage is that models help managers to take decisions faster and more accurately. And the third one is that they typically offer convenience and cost advantages over other means of obtaining the required information on reality. And the fourth, very important, is that the large and complex problems can be solved with ease. And the last one, models acts as a communicator to others by providing information and impact in changing conditions. So these are some advantages of mathematical modeling. Now we'll move towards different types of models. So let us have the first model, that is the physical model. A physical model, most commonly referred to simply as a model, but in this context distinguished from a conceptual model, is a physical model is a small or larger physical copy of an object. The object being modeled may be small, for example an item, or large. You can take an example of solar system. Solar system का एक physical model भी हम लोग ले सकते हैं. And the next type is conceptual model. A conceptual model is a representation of a system that uses concepts and ideas to form said representation. Conceptual modeling is used across many fields, ranging from the sciences to socio-economic to software development. For example, in the realm of software development, a conceptual model may be used to represent the relations of entities within a database. Whether written down via text or diagrammed visually, such a conceptual model can easily represent abstract concepts of the relationship between objects in the system, such as users and their relationship to accounts. Now the next is scientific models. Scientific models is a physical and or mathematical and or conceptual representation of a system of ideas, events, or processes. Scientific models are used to explain and predict the behavior of real objects or systems and are used in a variety of scientific disciplines, ranging from physics and chemistry to ecology and the earth sciences. Now, next is learning models. Learning models are any framework that defines the mechanism of learning. Basically, a learning model is any form of learning new skills or information. These models have categorized that further divided into various learning styles that I will take up in the coming slides. And the next one, which is very important, is digital model. Nowadays, it is very useful for us also for taking online classes. Digital models is the process of creating a computer model of an object that exactly replicates the form of the object. Now, let us move towards the next type, pedagogical models. Pedagogical models are those models which teachers sometimes provides to students so that they better understand some mathematical concepts. The pedagogical model describes what effective teachers do in their classrooms to engage all the students in intellectually challenging work. And we'll see the details in the coming the slides later. And now let us move toward the next one, that mental models. Mental models are how we understand the world. Not only do they shape what we think and how we understand, but they shape the connections and opportunities that we see. Mental models are how we simplify complexity, why we consider some things more relevant than others, and how we reason. A mental model is simply a representation of how something works. We cannot keep all of the details of world in our brain, so we use some models to simplify the complex into understandable and organizable chunks. Next is modeling a phenomena. So, modeling phenomena, we often understand real life phenomena through these models. To be able to do this, we need to be aware of the basic and the operation of modeling and the methods of its application. Modeling should be used not only for understanding but also for predicting real world phenomena. And the last one is the modeling real world problems, real world situations, like population growth, कोई भी रियल वर्ल्ड प्रॉब्लम्स को मॉडलिंग करना. सो पॉपुलेशन ग्रोथ, disease propagation, traffic flows, population dispersion, earthquake impacts, climate and energy prediction models are widely used to plan for the sustainable use of resources and management of the natural and built environment. Using real world examples drawn from physics, chemistry, biology, and earth sciences, this subject introduced students to framing this sometimes complex systems, firstly as complex conceptual models, then as logical and mathematical models. So these logical and mathematical models are then brought to life using tools such as software representations and simulation for the system of interest. Now, let us move toward the next one, the example of modeling a real world problem, one very important that we are facing, that the COVID-19, the COVID-19 problem. So in COVID-19 problem, which is a real world problem nowadays, this is a real world problem. If you want to understand the nature of COVID-19 through mathematical model, we can choose any particular issues. Like we know that due to COVID-19, there were so many issues came up, which are facing, like we saw migrant workers going back to their native places, and there was no transport available for them. So that came out a big problem for our country. And then there was inflation in like almost in all the basic essential things, prices have hiked. So these things are affected our day-to-day life. We can also study the natural budget. We can also study our daily budget through mathematical modeling, and demographic nature of COVID-19 also we can take up: age, gender, race, culture, country, states, economic class. And I will show you one website also based on this COVID-19 mathematical modeling. This one, COVID-19 mathematical modeling. So this is the website. Uh, this website is created by Centers for Disease Control and Prevention organization, and here the number of US cases or deaths that are done by using mathematical modeling. So I will share this link to all of you through chat box. Cases and death. So these are denoted represented by some data has been given. So graphical way representation, some other type of representation is there. So these are the real life problems are there. So this can be done by using mathematical modeling. Now I'm going to explain the process of mathematical modeling. So this is the website, and let us discuss about the process of mathematical modeling. So first, what we will do, we will understand the problem. We will take up the real life problems and we will understand the problem. We will define the real problems, and if works in a team, discuss the issues that you wish to understand. Simply by making assumption and ignoring certain factors so that the problem is manageable. So that is the first step of the mathematical modeling. Now we'll move toward the second step, that is simplification part. Describe the problems. So this is the second part. Describe the problems in mathematical terms. Okay, so described in mathematical terms the different aspects of the problems, some ways to describe the features mathematically, which includes define variables, write equations or inequalities, gather data and organize into tables, make graphs, and calculate if probabilities there, calculate probabilities. That all will comes under this second step, that is mathematical description and formulation. And the next step is solving the problem. Now solving the problem, the simplified mathematical problem which we did in this formulation part, that develop in the step number 2, is then solving using mathematical techniques. So that is the step number 3. And step number 4 is interpret the solution in the real life situation. The solution which we obtained in the previous step is now looked at in the context of the real life situation that we had started with the step number 1 from here. Now the last step is that validation. So now validating the model. If we go back to the original situation and see if the result of the mathematical work makes sense. If so, we use the model until new information becomes available or assumption change. Sometimes because of the simplification assumptions we may lose essential parts of the real problem while giving its mathematical description. In such cases, the solution could very often be off the mark and not make sense in real life situation. If this happens, we consider the assumption made in step number 1. Okay, we'll go back this step. After understanding the simplification part, we will go back to this step and revise them to be more realistic, possibly by including some more factors which were not considered earlier. So this is the process of mathematical modeling. So I will give one example based on this mathematical modeling. So let us see one example. Estimation of fishes in lake. So step number 1, the understanding the problem. So suppose our problem is to estimate the number of fishes in a lake. It is not possible to capture each of these fishes and count them. So we could possibly capture a sample and from it try and estimate the total number of fishes in the lake. it may be not exactly the population, the number of fishes present in a lake, but somewhat some extent it may be the we can consider it as a equal number of fishes. Okay, so now then so this is the picture. This is a small pond with full of fishes. So now step number two. Now step number two is mathematical description. Now what we will do here, we will take a sample of some 20 fishes from the lake, and we will mark that 20 fishes we will mark them, and then we will release in the same lake so as to mix with the remaining fishes. I will repeat, we will take a sample of 20 fishes and we will mark them all, okay, and then we will release them in the same lake so as to mix with the remaining fishes. We then take another sample of 50, say 50 fishes from the mixed population. Mixed population means the 20 which we marked earlier, and that 20 we mixed with the remaining fishes. Now we are going to take the 50 fishes, sample of 50 fishes from the mixed population, and see how many are marked. So we gather our data and analyze it. Okay, so now step number three. So suppose we got 20 five fishes which we marked earlier. Okay, 5 fishes out of 20 samples. Suppose in the second sample, in the example number example in step 2, 5 fishes are marked. So our fraction is 5 by 10, 5 by 50, that is 1 by 10 of the population is marked. Okay, so 1 by 10 of the population is marked means that is 20. Okay, if this is typical of the whole population, then 1 by 10 of the whole population will be equals to 20. So the whole population will be 20 into 10, that is 200. So this is the estimation. This is the step number 3. Now step number 4, when we go to interpreting the solution. Step number 4, interpreting the solution. The solution obtained in the previous step is now looked at, and in the context of the real life situation that we had started with the step number 1. For instance, our solution in the step number 3 gives us the population of fishes as 200. Now after that, the step number 5 is validating the model. We go back to the original situation and see if the results of the mathematical work make sense. If so, we use the model until new information becomes available or assumption change. So in this way, we will take a real life situation, and we will take a use of mathematical modeling. I will give one more example. Simple interest. So step number 1, understanding the problem. So this is the problems. Suppose Ajay has invested rupees 15,000 at 8% simple interest per year. With the return from the investment, he want to buy a washing machine that cost rupees 19,000. For what period should he invest to rupees 15,000 so that he has enough money to buy a washing machine? Okay, so here we know that the principal and rate of interest we know, and interest is the amount Sudhir needs in addition to these 15,000 rupees, okay, to buy the washing machine. So we have to find the number of years. So that is our understanding of this problem. Now the next part, the mathematical description and formulation part. So the formula for simple interest is I is equals to P into R into T upon 100. So this is our model, where P is principal and R is the rate of interest and T is the time period, the number of years. And here the principal amount is rupees 15,000. So money required by Sudhir for buying a washing machine is rupees 19,000. So the interest to be earned will be 19,000 minus 15,000, that is 4,000. So the number of years for which rupees 15,000 is deposited is let it be T. We are going to take it as a T, and we'll substitute I in this model, that is formula, and P, that is 15,000, and the rate of interest is 8, and the time we have taken T. So if we simplify, we will get I is equals to 1200 into T. Let it be equation number 1. This gives the relation between the number of years and interest. If rupees 15,000 is invested at an annual interest of 8%, now we have to find the period for which the interest earned is rupees 4,000. So putting I is equals to 4,000 in equation 1, will get 4,000 is equals to 1,200 into T. This is T. So now we have formulated the relation the mathematical expression for finding the value of T. Now we are going to solve the mathematical problem. That is step number 3. So solving equation 2, we get T is equals to 4,000 upon 1,200. So if we simplify, we'll get T is equals to 3 1 by 3 mixed fraction. Okay, now we will interpret the solution. Since T is equals to 3 1 by 3, that is 3 years and 1/3 of a year, we know that it is equals to 4 months. So Sudhir can buy a washing machine after 3 years and 4 months. Okay, so now we have to validate that whether it is possible or not. So definitely this is possible. After 3 years and 4 months, he can buy the washing machine. So that is the validating the model. Now I will going to discuss about the what is the difference between the conventional model and this mathematical modeling. So in convention modeling, before that, let us discuss about the curricular expectation of the NCRT. I took this from the I took this snap from the NCRT book, and just go through the first point, that is mathematization ability to think logically, formulate and handle abstractions rather than knowledge of procedures, formal and mechanical. So the similarity which our curricular expectation kind of noted, and like the similarity which we have in the mathematical modeling, the teaching of mathematics should enhance children's ability to think and reason, to visualize and handle abstraction, to formulate and solve problems. Access to quality mathematics education is the right of every child. And the second one is mathematical vocabulary. So knowledge of maths vocabulary is an essential component of learning mathematics. In order to communicate math thinking clearly, students need to learn and use appropriate vocabulary. So some strategies also we can use to teach maths vocabulary. Suppose we can start with what they know and use student friendly definitions, uh, and teach new maths words and give students multiple exposures to math words. And we can set up a classroom, that one corner math word wall, or individual math word banks. Also we can use math journals also to develop the mathematical vocabulary. And the next part is the consolidation and generalization of the concepts learned so far. So by looking the pattern, first we have to represent the data in a more meaningful way. For example, in a chart form, in a graph form. We know that COVID-19 data was also represented in a graph form. How the number of cases increases at one point, and it will reach at the peak, and then slowly it will go down, because now people will also develop the immunity. And there are people who are defending for the case of hard immunity. If the hard immunity develops, then cases will reduce. All these will be more clear when we are presenting in a graphical nature. And the next one is understanding and proving mathematical statement. I will give one example. In the factor theorem, you are given a polynomial that is p of x, and told that p of a is equals to 0. So you have to use this to show x minus a is a factor of p of x. Similarly, for the converse of the factor theorem, you are given that x minus a is a factor of p of x. And you have to use this hypothesis to prove that p of a is equals to 0. And the next one is addressing problems that come from other domains such as science and social sciences. So this is the problem with our curriculum, that when we are dealing with the topic, sometimes we are fixated with our maths concept only, and not only that we are teaching algebra, then we are just fixed ourselves with the algebra only, and not we will not connect it with the other problems which are present in science, especially in physics. And for example, equation of motion, if we take the linear equation in first equation of motion, that is v is equals to u plus et, and even quadratic equation in second equation of motion, that is s is equals to ut plus half at square. So like that, we should not fix ourselves with the mathematical concept. We have to uh, address, we have to take other domains also sometimes. And the next one is integration of concepts and skills that the children have learned into a problem solving ability. This is the another point which also is to some extent same line, where we kind of connected with the children's own knowledge, and like varied form of knowledge and skills. We should not fixated with one particular concepts. Like if I am teaching geometry, then I'm fixated with geometry, but need to integrate maybe uh, geometry with the sense of measurement, measuring the earth, measuring some given area, and also with some special real life problems, and which are related. We can take our problems related to social science also, and sciences also. So all these things we need to consciously do, which we are doing when we are doing mathematical modeling. So all these points won't be possible to do if we restrict ourselves to the curriculum objectives. So we need to broaden our perspective to like bringing all these meaningful context for the learners. And the next one is analyzing and constructing the processes involved in mathematical reasoning. So mathematical reasoning is the critical skill that enables a student to make use of all other mathematical skills. With the development of mathematical reasoning, students recognize that mathematics makes sense and can be understood. They learn how to evaluate situations, select problem solving strategies, draw logical conclusions, develop and describe solutions, and recognize how solutions can be applied. Now, the last one is establishing linkages between mathematics and daily life experiences and across the problem, which again is very important point for doing mathematical modeling, which we already I said that mathematical modeling, the important aspects of modeling is when we connect it with some real life situations. And nowadays in class 10th CBSE also, not only in mathematics, in all the subjects, that case study based questions are has been included. Case study based is nothing but that is taken out from real life situation with related with our curriculum. So in class 10th also four case study based questions are there in mathematics. In science also four case study based questions are there. So now we'll move towards the difference between the conventional and mathematical modeling. In conventional modeling method, we learn the facts, we follow procedure, we learn the definition, and we learn the theorems. We just practice the proof of the theorem, and it is very results and solution oriented only. But when we are doing mathematical modeling, when we are doing mathematical modeling aspects, we collect the data from the scratch. We follow more conservative or we can call it as a construction list when we are using a digital platform, and where children construct their own mathematical knowledge, they construct their own definition, they construct their own understanding. Once they have a kind of constructed, they evaluate. Now the next stage, they evaluate if they established it to a given observation or data. So collecting data is the same as observation. We can observe some phenomena. We can also kind of quantity those observations and collect data in terms. Once when we evaluate and establish, we will generalize. We will generalize. We'll also find some patterns. We'll also kind of use an algebraic equations, and based on that, we can predict what will be the future results. We can also infer the situation in a more meaningful or more better way or deeper way than just seeing the result. Once we understand, once we do all these activities which are listed, we understand some phenomena in more deeper way. Now I'm going to take up one example, is a learning model. The weekly wages in rupees of 30 workers in a factory are given. These are the example, only weekly wages is given. Now my question is that how do we represent this data? So you can unmute and you can give your answer. How do you represent the given data of 30 workers?
Using class intervals and frequency distribution.
Okay, very good. Okay, by using tally marks we can format a frequency distribution table, right? Any other way?
Histogram.
Histogram. Okay, fine. Any other way we can represent the data?
Frequency polygon.
Frequency polygon. Okay. Any other? What you can do with this data? What you can represent the 30 workers ka data hai. So what you can find it from this data? You can represent it in graphical form, that first frequency distribution table. Graphical form, you just told that histogram, frequency polygon. Any other?
Pie chart.
Pie chart, other than graphical representation.
Pictorial representation.
Other than pictorial and graphical representation, what you can do this with this data? Suppose data is given.
You can calculate the mean and
Very
tell
good.
how many above
Okay,
mean
very good, madam. You can calculate the mean. Any other?
Mean, mode, median, anything?
Yes, we can arrange the data in ascending order, and then we can find the median, and we can.
Median.
Yes, madam.
Even mode cannot be. Mode also can be done.
Yes, mode also can be done. So these are all the examples of the modeling only. Okay, so I have taken up that problem into frequency distribution table. After that, I have represented in the histogram. Okay, so these in this way we can represent any real life situation problem. Now we'll move towards one very important part, that is digital models. So these are some digital models which anybody can use while teaching online also. So I will show one demonstration. Let us take. I will give this link in a WhatsApp group. So I will show one demonstration. So this is geoboard. So shall I show one this geoboard?
Yes, sir.
Okay. When you open this, you have to open through web app. Okay. So you click on that one. So one geoboard will come here. You can take in any other form. This is square form. This is rectangular form. This is circular form. So I'm taking one rectangular form. So you know what we can teach student by using this geoboard. You can teach the shape of different quadrilateral. Suppose you have to take rubber band from here. Suppose I want to draw one square. Like that. This is a square, all four sides are equal, and each angle is 90 degree. So any figure you can make and you can demonstrate in this digital model. You can explain the, even you can explain the theorems also of class 10, that is basic proportionality theorem, using this one. But usually we are taking up this workshop only restricted to class 6 to 8. So we can have, you can teach the different types of triangles by using this model. Another model, so many apps are there, not only this one. Geoboard, math clock, you can teach the fractions, number frames, number line, number pieces, number racks. You can see later, I will share this in chat box. Right, already shared. So now let us move towards one more digital model that is available in the website mathsisfun.com. So this platform is also very useful for taking up through online. I'm giving one example of this one. So this is a balance one, and we can balance the equation to get the value of x, that is the solution. Suppose here 4x is there, so I want x to be here. So what I will do, I will subtract x. Okay, and again I want to remove this plus 2. So what I will do, I will subtract minus 1 to this side, both sides. Yes. So in this way, we can use this model also to for solving the linear equation in one variable. And if we click here, another one more equation will come up. So we can balance and we can solve the equations by using this model. So these are examples only. So even in the presentation also you can use these examples. So many puzzles and games are also there. So now let us move towards the another one. Now we can teach students through turtle. One turtle game is there, and turtle's logo and simulations is also there. That also I will demonstrate and I will show you. This is the turtle game, and here this is a free version. Actually, one platform, Clicks platform, is there. So many this web apps is there we can use. So I am using this turtle blocks. So this is a free version only. So we have only three tools for moving this turtle. So what we can teach using this game also, that I'm demonstrating. Suppose I'm taking all this here. We have to drag and you have to take here. Now I want to move forward. Suppose I want to draw one square using this game. So we have to click on this one, forward, 2 times. Okay, now I want to move right 90 degree. So here this we will type 90 and we will click on 90 right. So it will move right angle. So again forward 100 because I want to draw one square, and that should be of or the length should be equal to each other. So 1 2. So again right 90 degree, forward 1 2, again right 90 degree, forward 1 2. So like that one square is completed. So in this way also the student may learn the different shapes by using this game. So now let us move towards the another one. This is the platform. I will share this link to all of you, and this I have already explained how to play this game. Now this is also one of the game uh, through which we can the student can test their knowledge based on the different polygons. So that also I will show you. This is level number 1. So here 4 figures are there, and we have to catch the culprit. So first we have to click on clue. The culprit has less than 4 straight sides. Now the student has to identify uh, the negative one, means the opposite one, to release them one by one. The culprit has less than 4 straight sides. So which one? 1, 2, 3, 4. Which could not be culprit, that we have to identify and we have to release them. Suppose if I click on this one, this is the wrong one, so I will lose my token. So again, so I'm replaying once again. After that we have to click. The culprit has at least 2 straight sides. At least 2 straight sides. Which we have to click.
Third one can be released.
Third one, चलो देखते हैं.
Third one.
नहीं, third one is culprit or we have to release.
Third one should be released.
Okay, correct. So we have to click on clue again. So this is released. Now the culprit has exactly 1 equal pairs of sides. So we have to identify in which exactly 1 equal pairs of sides are there.
First one. First one.
But we have to identify to whom we have to release. So whom you want to release?
And then the third, last one.
So shall I go for this one?
Fourth one.
Okay, fine. So token lost.
Second also.
Also we can release.
Okay, I will restart once again. The culprit has at least 1 curved side.
We will release third one.
Yes, we will release the third one. Okay, fine.
So first
Third will be released.
Okay, third will
First
be
and third.
released. Next one, the culprit has at least 1 straight side. At least 1 straight side.
We will release fourth.
Fourth one.
Fourth one. Okay, fine, good. Now the culprit has exactly 1 equal pairs of sides.
We will release
Second
second.
one. Second also released.
Yes. So fabulous work, you caught the culprit. Like that, this is a game where the student can learn the different types of shapes and okay, now let me close this one. Another useful simulations is that PHET interactive simulations. So I will show one example. This is the website. This is the web page. Already I have given this website address in my slide. So let us start this area builder. I have already opened in my next tab. So if we see, this game is very useful to learn the fraction and the area also, perimeter also. See, it is like a puzzle only. Area is given 40. Half of this 40 is light shaded and half of this is dark shaded. And the perimeter should be equals to 28. So half of 40 is 20. So this is 1 unit. So let us start with this one, the light one. So 40 means 10 into 4. We can take 10 into 4 because the perimeter should be equals to 48. So 2, 6, 8. We'll take 1 this side and 1 this side. So 10 over. Again, we'll start from here. 1, 2, 3, 4, 5. So this is the light one is over half. Now I'm going to complete the dark one. 1, 2, 3, 4, 5. One more set. 1, 2, 3, 4, 5. Now after completing, we'll check whether the area is 40. Definitely 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 4. 10 into 4, 40. And perimeter 10, 10, 4, 4, 28. So we'll check. When we'll check, it will display the, it will give the point. Otherwise, it will say wrong. So I got the correct answer. If suppose I will not give the correct answer, then what it will happen? So 3 by 4 of 24 is dark one, and 1 by 4 of 24 is light, that is 6. So I will randomly I will put and I will check wrong answer. Okay. So if suppose I'm giving up to here only, so it will give wrong answer. Okay. So again we can try once again. Okay, once again we can try and we can check. So this, in this way also we can use this model, this game also to teach fraction. The children will enjoy by playing this game, and they will learn fraction and area and perimeter. Okay. So these are the different types of digital models you can use it in your online teaching. Now let us move towards the next section, that is pedagogical model. So pedagogical model, as I already told, that these are the models those which teachers sometimes provides to students so that they better understand some mathematical concepts. For example, we use a mathematical multiplication table of 6, and this division of integer models, integer mall, and 3D shapes, different 3D shapes, fraction model for multiplication. The pedagogical model describes what effective teachers do in their classroom to engage the students in intellectual and challenging work. It provides an overview of the learning cycle and breaks it down into 5 domains or phases of instruction. First, let us see if the 5 domains of pedagogical model. The first one is engage. The first one is engage. Teachers know their students well and engage them in building supportive, inclusive, and stimulating learning environment. Teachers motivate and empower students to manage their own learning and develop agencies. Now, the next one is the explore. The teacher present challenging tasks to support students in generating and investigating questions, gathering relevant information, and developing ideas. They help students expand their perspective and preconceptions, understand learning tasks, and prepare to navigate their own learning. And the third one is explain. Teachers explicitly teach relevant knowledge, concepts, and skills in multiple ways to connect new and existing knowledge. They monitor students' progress in learning and provide structured opportunities for practicing new skills and developing agency. Now, the next one is elaborate. Teachers challenge students to move from surface to deep learning, building student ability to transfer and generalize their learning. They support students to be reflective, questioning, and self monitoring learners. And the last one is evaluate. Teachers use multiple forms of assessment and feedback to help students improve their learning and develop agency. They monitor student progress and analyze the data to draw conclusion about the effectiveness of their teaching practices, identify areas of improvement, and address students' individual needs. So these are the uh, five domains of pedagogical model. Now let us move towards the individual work for today's. Actually, I have deleted two examples from today's session. And this is the individual work. What you have to do, you have to take a problem or real life situation and identify a real world mathematical model situation, list the assumption, read, create, list down, find the data points, analyze and visualize the data points represented as graph or any other form, make conclusion and future predictions, give the significance and importance of the model. So this is the individual work which we are going to give today. And you have to complete individual work, and you have to submit one through one link which I have given in the chat box. Even in WhatsApp also I have given. This is the link. If you click on this link, then one form will appear. You have to fill your particulars, then you have to upload the file which you have prepared, either in the form of document, doc file, or presentation, or even video also it will accept if you want to present. So this is individual work and you have to submit through this Google form. After collecting all, I will forward to the course director, and after collecting all the groups, we will share with all the participants through the registered mail. So this is the individual work for participants. Now we'll move towards the group work. Group work for all the participants, that you have to do this in a group. The first one is to identify a math topic, model it into real world context, and then variation, list out the learning outcomes from that math model. And the next one is that identify a real life problem and representing that real life problem in a mathematical form, observations, data, or generalization, or list. You can use some patterns also, graphs also, and after that list out the learning outcomes. So these are the group work for participants, and every group has to present. The time allotment for the presentation will be 15 minutes. Within 15 minutes, they have to complete their group presentation. Okay, so thank you very much to all the participants. Thank you very much.